The topic for my research proposal is emotional intelligence in voice interactive chatbot recommendation systems. And the topics that I'm covering in this presentation is a research overview and what is the research question, why voice interactive chatbot, how chatbot integrate with the recommendation systems, what is the data set I'm using, what are ethical guidelines that I'm following, followed by the methodology and conclusion. To tell you about the importance of emotional intelligence, I'll take an hypothetical example of me interacting with the commonly known chatbot Apple Siri. My main aim here is to know a place that I want to hang out with my friends. So I'm asking the Siri, can you suggest me some places to go? And it had given me, um, it asked me to select some options from it, and I choose to go with the temple bar, and then I followed up with the question of can you tell me about what is the rating of the temple bar? And it have given me the rating. And the problem here is it's all working fine, but it is not a human conversation. So it lacks the understanding of the emotion that you are speaking to it. And if it knows that you are speaking with the sadness or happy, then it can alter it may alter its suggestions for you. My research is regarding that. So and yeah, regarding the business impact and the business point of view, the recommendation systems are playing a key role in not only one sector but in various sectors, especially in automobile safety, travel, hospitality, e-commerce, etc. And the chatbots will obviously play a crucial role here, as most of the state-of-art recommendation systems rely just on the past information uh, mm, without being able to adjust its suggestion based upon the feedback from the user and in the emotion in which the user is interacting to the chatbot. And the research question that I'm trying to answer is, in the context of voice or speech emotion recognition in chatbots, interactive recommendation systems, which are the machine learning techniques, naive-Bayes, KNN, MLP, C4.5, and random forest, are less error prone, and if so, by how much? And the reason for me choosing the voice chatbots is because this is new and emerging, and there is very less research that is happening in this area, and there is a lot of scope for me to contribute in this area. And yeah, okay. This is the flowchart of the recommendation system integration of the chatbot, and it is taken from mm, the conversation strategy of chatbot of integrating systems by Y. Kimoto et al. And let me go back there. Yeah, okay. Yeah, so it basically uses the addition and subtraction of this vector depending upon the user feedback, and it get adjusted to the threshold so that it can recommend you some new items based upon the user feedback. And I highlighted these two in red because here when obtaining the user feedback, the traditional chatbots are really relying on the past information of the user, or the words or the voice the user uses to it. But if it can understand like humans in what mood or emotion that the user is interacting with the chatbots, the threshold of the vector, the changing of the vector, the addition and subtracting of the vector can be made more specific and precise and efficient. And the dataset that I'm using to do my research is taken from an open repository called Rapdes, and it consists of 7,356 speech recordings, and it is rated 10 times emotional validity, intensity, and genuineness. And this Rapid database is balanced according to the gender. That means it uses both the male and female voices in it, so that it is not biased to only to one gender. And it has the speech contents for the label speech contents for the calm, happy, sad, angry, fearful, surprise, and disgust expressions. And all the speeches are available in wave format, and when I'm doing my research, my utmost priority is to do all my research in ethical compliance, and this is considered because of the GDPR Act that is coming in, and the before acts that are there since 1988 and 2003 to use the data more ethically in the research also. So, and all the technologies that I'm using, or Python, Tableau, and all are legal and have all rights to publish my work in that. And the data used here is not to harm any individual privacy and security. Yeah. The methodology. My methodology consists of feature extraction from the audio files, what are the models that I'm using, and how I'm gonna evaluate the models. Feature extraction. Yeah. The main problem in using the audio files is they are not actually into any mathematical data or textual data to perform any machine learning algorithms on it. So my main hurdle here is to extract these mathematical features like mean, median, standard deviation from the features of the audio file. There are basically two kinds of features to extract that is been doing in the literature review. They are prosthetic features and spectral features, and I decided to choose both the features because to attain more efficiency. And and the this the and I am getting the pitch from and I will be getting a pitch from the speech signal using this formula, and I'm getting the mel frequency septal coefficients from these two formulas, and short term energy I'm getting from these formulas, and okay, and my model to test. And the reason for me choosing the naive Bayes is classifier is because it is highly scalable and fast when building a model, and it can deal with both the binary and multi-class classification problems. It is highly suitable to run the model, my model specifically. And the reason for choosing the MLP is that the data after extraction of the features from the speech signal tend to be more distractive and non-linear. And MLP's main strength is that it can differentiate the non-linear data using the multi-layers. And the reason for me choosing the C4.5 is because it starts at the root of the decision tree and grows towards the leaves. That is done based on ID3 algorithm, and and there is a lot of research that is going that went through and they attained the good results with 4.5. And the reason for me choosing the random forest is just because it has the capability to find a significant variable of all numerical variables, and my intuition is also that the random forest performs better of all the classifiers here. And I'll be using the confusion matrix to evaluate all my models to know about its accuracy, specificity, and its sensitivity, and based upon the true positive, true negative, false positive, and false negative values. And uh, and and finally, this is my Gantt chart that I'll be going. This is my schedule that I'll be implementing in my research in the span of 12 weeks. The span of 12 weeks, and it will be starting with the approval from my supervisor. And once I get the approvals, I'll go ahead and clean my data and transform and make it ready for the future extraction. And mm, I'll perform my future extractions, and then I'll start doing my machine learning models with simple techniques, and then I'll go ahead with sophisticated models, and then I evaluate all the models, followed by the proofreading and submission of my proposal. Yeah. So, and finally, to conclude, I am pretty sure that I can achieve my motto of integrating the chatbots with emotional intelligence and the recommendation system with the methodology and the feature extractions that I'm using and outlined in this research. And I'll be strictly following all the ethical guidelines, and especially keeping in mind the GDPR Act that is coming on and in May of this year. And thank you very much for listening.